Hi, my name is Muhammad Shukri bin Abdul Rahim. Today I would like to introduce you the cruise control system. What is cruise control system anyway? It's a system that automatically controls the speed of a motor vehicle. Why we need these devices? The major purpose of these devices was invented is because these devices are able to give ease to drivers to drive in a car. Within that, it implies that driver does not have to control the pedals, or in other words, pressing the gas and the brake pedals for much of the time, and can be said less tiring for the driver at the same time. Now, I would like to show you the basic block diagram of a cruise control system. As you can see from the basic block diagram, the first one we know that is an input. It's a desired speed of the car. Then from input it goes to the controller where the PID are. Then it goes to actuator where the engine throttle body flap angle. Then it goes to the plant where the engine control are located. Then finally it goes to sensor, which is the speed sensor that are able to detect the speed of the car to send a signal to the output, which is the actual speed of the car between input and output.
Hello, I'm Ashraf. I'll be presenting about the advantages of control system. As an article by Carson Max about fully integrated automotive radar system with versatile resolution, it states that the system has high flexibility with its modular system, in which, let's say, the system was built for sequential lobbying. So parallel lobbying cannot be paired into the system. So with the modular system, the authors can easily modify the system so it can be used for another type of system, and it also has high durability, versatility, and stable antenna with less moving parts. And next, moving on, I'll be talking about vehicle recognition and tracking from road image sequence by Gianluca Foresti. The author states that the advantage of the system is its ability to track multiple vehicles in the road traffic and able to convey the problem of occlusion in the road, so will be known to the environment, and also it has high robustness. The system is also stated that it is versatile with its capability to handle many functionality in one car, because in this system it consists of few control systems which significantly changes the efficiency of the system. Next, I'll be talking about Robert D. Inderkar in his article of control of switch reluctance drive for electric vehicle application. He states that the system is versatile due to its capability to have many functionality in one car. So, and he also states that the system is highly efficient and it has a control which can operate 3 functions at a time simultaneously. And lastly, it also offers robustness and less computing capacity because of the high switching frequency, and is lower in a given current. Thank you.
Hi guys, my name is Muhammad Zafran bin Muhammad Noor. Before this, my friend has talked about advantage of cruise control, and now I will talk about this advantage of cruise control. For the first article, I want to talk about the disadvantage. From the article, fully integrated automotive radar sensor with versatile resolution that authored by Carson Max. The disadvantage, the system such as that is high cost as it uses a gun diode, which generally has a bulky structure which relies on quasi-optical concept or mechanical scanning. Then the systems are often burdened with tasks that complicated the system integration, and it increased the cost as well. For the second article, For the article vehicle recognition and tracking from road image sequence, the author by Gianluca Foresti, the system is not be able to address the problem of road scene recognition and is limited to one characterized regulation. For the third article, the control of switch reluctant drive for electric vehicle application by Robert B. Enderka, the structure of the whole system are complex and the maintenance is proportionally more expensive, and the system usability can only be used in low-cost application. The system also cannot be put under extreme stress and the algorithm is limited. Thank you.
Hi guys, my name is Fikri. So as my friends have talked about the cruise control system, I will now show you how to construct the graph produced using the transfer function in the article. There are two ways. First is open loop system. Second is the closed loop system. The open loop system does not require a controller, while the closed loop system uses a PID controller. The two methods will be shown by using MATLAB and Simulink. Alright, let's get started. Alright guys, let's get started. First things first, you gotta switch on the MATLAB application. So what we're gonna do now is I'm gonna show you how to construct closed loop and open loop system using a Simulink library from the MATLAB. Alright, so here's the Simulink library. Let's take it out. Okay, the things that you need to construct a closed loop system. First, from here we'll take, from the commonly used block, we'll take scope, sum, and from the continuous section we'll take the transfer function, PID controller, and from the sinks, a scope we already took from the commonly used blocks, and sources we'll take this step. As you can see from the from where I've clicked, I've already taken the privilege to take it up for you. Alright, for the transfer function, we have to fill in the numerator and denominator coefficients. For the numerator, this numerator and denominator, we took it from the article, where it is a third order function. As you can see, there's 1, 2, 3, and 4. If there's 4, it means it starts with a third order, as the power of 3, and then s to the power of 2, s to the power of 1, and then a constant 0.238. Numerator will be using 2.4767. Okay, so the PID controller, I will be using a constant of 3 for the proportional, and the integral is 0.1, and the derivative will be 3. As you all know, for the closed loop system of this transfer function, the graph results will become a critically damped graph. So therefore, alright, let's just get it here. Okay, the time here we need to change it to 20 seconds. So because in the article it already stated that the runtime for this closed loop system and the open loop system is 20 seconds. Alright, so let's run it. So from the scope, we'll press it, and then we'll use auto scale. Alright, you can see here the graph is critically damped, as its rise time is less. So it's between 0 to 1 for the rise time, and it shoots directly upwards and becomes constant. We can see that this is a critically damped graph. Alright, okay, the difference between closed loop system and an open loop system is that the article says that we don't need a controller, so we'll just remove the controller and the summing junction, and we'll connect this to, okay, alright. Okay, The same conditions for the transfer function, we'll be using the same function and 20 seconds of runtime. So let's run it. Open the scope. Alright. As you can see here, the graph shoots constantly like medium time, so we can see that it's not a critically damped graph, but we can see that it can become an underdamped graph. So, but we don't know the characteristics yet, so it can be proven or be seen by using codings. Alright, that's all from me. Thank you.
Okay. Hi guys, my name is Devan, and today I would like to talk about the open loop system. For the open loop system, the step response we obtain is a overdamped system. So to prove it, it's a overdamped system due to we use a third order system in the denominator. So we use the root locus to prove it. So using the root locus, both poles are different real values. So it means the graph obtained is overdamped. So for the graph and the root locus, it maintains the same overdamped system. Okay. For the closed loop system, the graph we obtain is a critically damped. But using the root locus coding, we obtain the underdamped system because both of the poles have real and imaginary values. Okay. Now for the graph characteristic, first we look at the settling time. Settling time is the time where the system reaches the 98% of its final value. For rise time is the time to rise the output of 10% to 90% of its final value. Okay, for the steady state error, it is the difference between input and output. Okay, for the peak time is the time where the highest value of amplitude is recorded. Thank you.
Okay, Assalamualaikum. My name is Muhammad Hashim Berusli. Okay, I want to talk about the controller that used in the control system. The controller that used in the control system is the PID controller. So PID is stand for proportional integral derivative control. Okay, PID is a control loop feedback mechanism that widely used in the industrial control system. Okay, in the PID we have three parameters. There is KP, KI and KD. Okay, KP is the proportional, KI is integral, and KD is a derivative. Okay, based on the table that you can see before, when we change the value of KP, there is proportional. The speed of what we call that response will increase, and the graph will increase in overshoot, and its steady state response, steady state error will be decreased. Okay, second, when we change the value in KI, that is integral, the speed of response will be decreased. The graph or overshoot also will be increased, same as KP, and the steady state error will be eliminated. Okay, the last one, there is KD for derivative. When we change the value of KD, the speed of response will increase and the graph overshoot will be decreased, and the steady state error will be no change. Okay, within this we can see that the PID controller can change the type of graph when we change the value in P, I and D. So for our graph that we obtain, as you can see in the result, we use KP, the value of Kp is 3, Ki is 0.1, and the last one Kd, the value is 3. Okay, so when we use the 3 of the values, we can obtain the result as you can see. Okay, that's all from me. Thank you.